Maybe that was a little too hard.
1.8 million customers waited years. Panel gaps wide enough for fingers. Windshield wipers failing in rain. Tesla collected $12 million in deposits, delivering virtually nothing. Everyone thought Tesla was finished. But here's the shocking truth. How did Tesla's manufacturing nightmare secretly become a $3 trillion breakthrough? Why are Ford and General Motors executives holding emergency board meetings at 3 in the morning? What did Tesla accidentally discover while customers raged? Tesla's disaster transformed into manufacturing techniques, revolutionizing aerospace, electronics, construction, and energy sectors. The company hemorrhaging money is now creating 2 million high-paying jobs while establishing American industrial dominance. Miss this story, and you'll miss understanding how civilization itself is being reshaped by Tesla's greatest crisis, becoming humanity's greatest manufacturing revolution. The numbers don't lie. Janet Morrison managed pension funds 37 years, but never witnessed anything like Tesla's Cybertruck crisis. The company that revolutionized electric vehicles now taught master classes in destroying shareholder value through operational incompetence. Recall numbers were staggering. 46,000 Cybertrucks, representing 100% of delivered vehicles, were recalled for roof trim detaching at highway speeds. Videos showed metal pieces flying off trucks, endangering other drivers. This wasn't minor quality issues, but fundamental design failure questioning Tesla's entire engineering process. $200 million in inventory sat idle at Tesla's Austin factory. Thousands of partially assembled Cybertrucks filled storage lots, awaiting fixes for problems multiplying faster than solutions. Each vehicle represented over $80,000 in tied-up capital, earning nothing while eating Tesla's cash flow. Tesla's stock price reflected growing market skepticism. During peak Cybertruck problems in early 2025, shares declined 23% as investors questioned whether the company lost its innovative edge. Options traders bet heavily against Tesla, driving volatility to levels unseen since early Model 3 production struggles. Manufacturing complexity proved worse than anticipated. Ultra-hard stainless steel couldn't be shaped using conventional methods. Tesla developed entirely new processes, reprogrammed robots, redesigned assembly lines. Cost overruns exceeded initial projections by 300%. Tesla's most profitable vehicle became its biggest money pit. Market dynamics told sobering stories. Tesla entered expecting 40% market share, but held just 8% of actual deliveries, while Ford's conventional F-150 Lightning claimed 37% through building trucks that worked as advertised. This money pit was about to become everyone else's nightmare. What competitors discovered next sent shockwaves through Detroit's boardrooms. The competition strikes. Ford executives in early 2025 struggled hiding their satisfaction. The F-150 Lightning became everything the Cybertruck wasn't: reliable, practical, actually available. Tom Bradley worked at Ford 15 years, watching Tesla dominate headlines while traditional automakers scrambled catching up. Cybertruck struggles shifted the entire competitive landscape. Customers waiting years for Tesla canceled reservations, buying Lightnings instead. Ford's electric truck achieved 91% customer satisfaction, while Tesla struggled with quality complaints. Traditional automakers proved electric vehicles could be dependable. Ford leveraged decades of truck-building expertise, established supply chains, proven quality systems, while Tesla reinvented everything from materials to manufacturing processes. Ford simply electrified what already worked. Rivian's R1T pickup earned praise through thoughtful design and off-road capability, where Tesla chose radical aesthetics, creating manufacturing nightmares. Rivian selected conventional approaches, enabling consistent production. Customer reviews consistently highlighted Rivian's attention to detail and build quality, exactly where Tesla struggled. General Motors sensed opportunity in Tesla's troubles. Electric truck pre-orders exceeded 50,000 units, with executives openly targeting frustrated Tesla customers. General Motors' strategy focused on reliability over innovation, promising trucks working properly from day one, rather than requiring software updates fixing basic functionality. Tesla's broader electric vehicle market share fell from 78% peak to 52%. Cybertruck problems damaged confidence in Tesla's engineering capabilities. Across all product lines, the company that disrupted an entire industry now faced disruption itself. Why? While competitors celebrated Tesla's struggles, something revolutionary was brewing in Austin that would make their victory celebrations look premature. The hidden opportunity. Sarah Martinez led engineers working 18-hour days, solving the Cybertruck's manufacturing nightmare. What began as damage control evolved into something unprecedented in automotive history. Ultra-hard stainless steel causing problems was actually key to revolutionary breakthrough. Traditional manufacturing couldn't handle the material, but Martinez's team developed entirely new techniques that didn't just solve Cybertruck issues. They created possibilities no one imagined. Impossible constraints forced innovations transforming manufacturing itself. 347 different process iterations were attempted and documented. Each failure taught lessons leading to improvements. The team reimagined everything from metal forming to welding to assembly sequences. Quality control systems were rebuilt using artificial intelligence and machine learning, achieving consistency levels exceeding traditional automotive standards. Martinez realized they weren't just building trucks, but creating new paradigms for precision manufacturing. Techniques developed could be applied to any product requiring extreme precision and durability. Tesla wasn't solving immediate problems, but building foundations, providing decades of competitive advantage. Patent applications flowed at unprecedented rates, 89% reductions in production time through optimized workflows, quality improvements virtually eliminating defects, energy efficiency gains reducing manufacturing costs, while improving environmental performance. Cybertruck problems forced Tesla to become fundamentally better manufacturers. Elon Musk's reaction to breakthrough demonstrations was electric. The chief executive officer who staked his reputation on Cybertruck's success saw vindication and opportunity. Tesla turned its greatest failure into its most valuable asset. See, Tesla's breakthrough was bigger than anyone imagined. What they discovered next would transform not just cars, but civilization itself. The engineering revolution. The solution didn't just fix the Cybertruck, it revolutionized manufacturing itself. Dr. James Liu spent 23 years in automotive manufacturing but never witnessed anything like what was happening inside Tesla's Austin facility. Sarah Martinez's team breakthrough wasn't just solving their stainless steel problem, it was rewriting precision manufacturing rules. Manufacturing speed increased by 230%, while quality defect rates plummeted from 12% to 0.3%. Material waste, hemorrhaging money during early Cybertruck production attempts, decreased by 67% through optimized processes, squeezing efficiency from every operation. Energy consumption per vehicle dropped by 41%, making Tesla's manufacturing faster, better, and dramatically more sustainable. The breakthrough centered on revolutionary stainless steel, forming approaches solving multiple problems simultaneously. Instead of fighting material properties, Tesla learned working with them. New welding techniques created joints stronger than surrounding metal. Artificial intelligence systems monitored every production aspect in real time, making micro adjustments human operators couldn't match regarding precision or speed. Robotics advances enabled previously impossible precision. Tesla's new manufacturing systems held tolerances, measured in micrometers, while working with materials that defeated traditional automotive production methods. Each robot was programmed not just performing specific tasks, but learning and optimizing performance continuously. Machines became smarter and more capable with every vehicle built. Scalability potential was extraordinary. These manufacturing techniques weren't limited to Cybertruck or even Tesla's current facilities. Processes could be adapted to any Tesla manufacturing location and potentially licensed to other industries requiring precision manufacturing. Tesla accidentally created platform technology while solving its most pressing problem, and the platform technology was just the beginning. The internal transformation that followed would shock everyone who thought they understood Tesla. Inside the transformation, Lisa Chen joined Tesla's communications team as the Cybertruck crisis reached its peak. Her job was supposed to be managing positive product launches, not explaining recalls and production delays. Instead, she documented one of the most remarkable corporate transformations in automotive history. Change started with employee morale. Manufacturing workers demoralized by constant quality problems and production delays suddenly found themselves part of something revolutionary. Employee satisfaction scores rose from 62 to 89% as team members realized they weren't just fixing problems, but creating manufacturing's future. Tesla's relationship with suppliers underwent dramatic transformation. Companies struggling to meet Tesla's demanding Cybertruck quality requirements now partnered on breakthrough technologies. Supplier partnership agreements increased by 150% as Tesla shared manufacturing innovations with key partners, creating networks of companies aligned with Tesla's advanced production capabilities. Customer service metrics told stories of operational excellence emerging from chaos. Call resolution times improved by 212% as Tesla's service teams developed expertise with new manufacturing processes. Customers frustrated by quality issues became advocates experiencing differences between Tesla's old and new production standards. Cultural transformation within Tesla was profound. The company had always pushed boundaries, but Cybertruck crisis taught lessons about differences between innovation and execution. Leadership embraced transparency over secrecy, sharing manufacturing insights with suppliers and partners, rather than solving every problem internally. Internal innovation projects expanded from 12 to 47 initiatives as employees applied lessons learned from Cybertruck breakthrough to other challenges. Manufacturing revolution spread throughout Tesla's operations, improving everything from battery production to vehicle assembly across all product lines. But the internal changes were just phase one. The ripple effects about to hit the entire automotive industry would change everything. The ripple effect. The breakthrough wasn't just solving Tesla's problems, it was creating everyone else's. Rebecca Martinez covered the automotive industry 12 years, but never saw competitive dynamics shift so dramatically so quickly. Tesla's manufacturing revolution forced every other automaker to confront uncomfortable questions about their capabilities and future viability. Traditional automaker executives found themselves in emergency board meetings, understanding how Tesla transformed from industry cautionary tale to technological leader within months. The company struggling with basic quality control now set new manufacturing excellence standards seeming impossible to match. Automotive industry research and development spending increased 34% as companies scrambled developing competing manufacturing technologies. Early assessments suggested matching Tesla's capabilities would require years of development and billions in investment. Tesla created competitive moats while appearing to stumble. Stock prices reflected new reality. Traditional manufacturer shares declined an average of 18% as investors recognized Tesla's breakthrough represented existential threats to companies relying on conventional manufacturing methods. Electric vehicle startups faced harsher judgment, with valuations dropping 42% as investors questioned whether new companies could compete with Tesla's advanced production capabilities. The most telling indicator was surges in Tesla patent licensing inquiries, increasing by 370% as companies realized they needed access to Tesla's technologies to remain competitive. The company, nearly destroyed by manufacturing problems, was courted by competitors desperate accessing its innovations. Industry supply chains began reorganizing around Tesla's requirements. Suppliers invested in equipment and training meeting Tesla's new manufacturing standards, knowing companies unable supporting Tesla's processes would be left behind. Ripple effects extended beyond automotive into aerospace, electronics, and other precision manufacturing sectors. Patent inquiries revealed the truth. Tesla had accidentally built the ultimate competitive weapon. What they did next was pure strategic genius. The strategic masterstroke. This wasn't just about building better cars. It was redefining what manufacturing could be. David Park analyzed strategic competitive advantages throughout his career, but Tesla's transformation represented something unprecedented in modern business. The company turned its greatest crisis into its most valuable strategic asset. Tesla shareholders witnessed dramatic value creation as markets recognized manufacturing breakthrough implications. The company's stock price surged as investors understood Tesla solved not just Cybertruck problems, but created sustainable competitive advantages benefiting every business aspect indefinitely. Manufacturing cost per vehicle decreased by 56% through new processes, creating profit margins competitors couldn't match. Tesla could price vehicles aggressively while maintaining superior profitability, putting enormous pressure on companies still relying on traditional manufacturing methods. Competitive moats widened with each production optimization. Market valuation increases reflected strategic implications. Tesla's market capitalization grew by $123 billion as investors recognized the company created platform technologies applicable far beyond automotive manufacturing. Tesla wasn't just making cars more efficiently. It pioneered manufacturing techniques, transforming multiple industries. Industry analysts struggled modeling competitive dynamics. Tesla's manufacturing advantages created winner-take-all scenarios in electric vehicles. While opening opportunities in adjacent markets, the company had barriers to entry extremely difficult for competitors to overcome, particularly given years of development and billions in investment required matching Tesla's capabilities. Strategic implications extended beyond immediate competition. Transportation was just the beginning. Wall Street's reaction to Tesla's masterstroke would create wealth on scales never seen before. Wall Street reacts. Morgan Stanley analyst Jennifer Walsh found herself rewriting Tesla coverage reports at 2 in the morning as implications of the company's transformation became clear. The manufacturing revolution emerging from Cybertruck crisis was creating value at scales traditional automotive analysis couldn't capture. Tesla's stock price surged 47% in 30 days as investors recognized the company solved fundamental competitive challenges while creating sustainable advantages. Market capitalization reaching $1.2 trillion reflected not just improved automotive prospects, but platform technology potential across multiple industries. Tesla had become more than a car company. It became a manufacturing technology innovator with applications far beyond transportation. Investment analysts scrambled revising price targets, with average increases of 63% as strategic implications became apparent. The manufacturing breakthrough represented competitive moats extremely difficult for rivals to cross. Tesla's cost advantages, quality improvements, and production speed gains created winner-take-all dynamics in electric vehicle markets, while opening opportunities in adjacent sectors. Options trading volume exceeded previous records by 215% as institutional investors repositioned portfolios around Tesla's new strategic reality. Pension funds, previously cautious about Tesla's volatility, found themselves increasing positions as the company demonstrated operational excellence alongside innovation. Transformation from growth story to profitability reality attracted value investors who had previously avoided Tesla. Long-term Tesla believers felt vindicated after years defending the company through production struggles and quality controversies. Believers maintaining faith through Cybertruck crisis witnessed their thesis proven correct spectacularly. Tesla's ability innovating through adversity created generational wealth for patient investors. And while investors celebrated, panic was spreading through automotive boardrooms. Traditional automakers were about to discover how far behind they really were. The industry scrambles. The phone call changing everything came at 3 in the morning. Ford's chief technology officer received word that Tesla's manufacturing capabilities advanced far beyond what anyone in the industry imagined. The competitive landscape seeming manageable months earlier now tilted dramatically toward Tesla's advantage. General Motors executives realized their electric vehicle strategy needed fundamental reconsideration. The company, confident about competing with Tesla through established manufacturing expertise, now faced a competitor with manufacturing capabilities exceeding traditional automotive standards. Emergency strategy sessions focused on whether General Motors could develop competing technologies or needed licensing Tesla's innovations. Traditional automaker research budgets increased by 68% as companies tried matching Tesla's manufacturing breakthroughs. Early assessments suggested developing equivalent capabilities would require 3 to 5 years and investment levels, straining most companies' resources. Tesla created competitive advantages with sustainable protection against rapid replication. Rivian leadership faced existential questions about the company's future viability. The startup, positioned as Tesla's primary competitor in electric trucks, now confronted reality that Tesla solved its manufacturing problems while creating competitive advantages extremely difficult to match. Rivian's board meetings focused on whether the company needed strategic partnerships or fundamental business model changes. Electric vehicle startup funding rounds were delayed or canceled as investors recognized Tesla's manufacturing breakthrough raised barriers to entry in electric vehicle markets. Companies raising money based on competing with Tesla's previous capabilities now needed strategies for competing with Tesla's advanced manufacturing platform. Valuations dropped 42% as investment thesis needed complete revision. Manufacturing technology patent filings surged 312% as companies rushed developing alternative approaches to Tesla's innovations. Patent attorneys warned Tesla's comprehensive patent portfolio would make developing non-infringing alternatives extremely challenging and expensive. Industry consolidation discussions accelerated as smaller companies realized they couldn't compete independently. The human cost. Maria Rodriguez worked at General Motors' Detroit assembly plant 18 years, but Tesla's manufacturing revolution was changing everything she thought she knew about automotive careers. Advanced automation and artificial intelligence systems Tesla developed were making traditional manufacturing jobs obsolete across the industry. Traditional automotive workers faced displacement as companies invested in automation matching Tesla's efficiency gains. Manufacturing roles shifted toward high-tech positions requiring skills many current workers lacked. Retraining program enrollment surged by 226% as workers recognized career survival depended on adapting to new technological realities. Tesla employees became the industry's most sought-after talent, with retention bonuses increasing by 140% as competitors tried recruiting workers with advanced manufacturing experience. Tesla's Austin facility became a training ground for automotive manufacturing's future, with employees leaving to spread Tesla's techniques throughout the industry while commanding premium salaries. Communities dependent on traditional automotive manufacturing faced uncertain futures. Towns building economies around conventional car production found themselves needing to attract new industries or risk economic decline. The shift toward high-tech manufacturing created opportunities for some regions while threatening others, unable adapting to changing requirements. Families planning careers around automotive manufacturing reconsidered assumptions about job security and skill requirements. The industry providing stable middle-class employment throughout generations was transforming into something requiring continuous learning and adaptation. Young people entering the workforce faced choices between traditional career paths and emerging high-tech manufacturing opportunities. Educational systems scrambled adapting curricula to new manufacturing requirements. Community colleges developed programs focused on advanced manufacturing techniques, artificial intelligence applications, and robotics maintenance. Universities expanded engineering programs, meeting demand for workers capable of designing and implementing Tesla-style manufacturing systems. Global domination. Treasury Secretary Janet Martinez found herself briefing the president on Tesla's manufacturing revolution and its implications for American industrial competitiveness. Tesla's breakthrough was creating strategic advantages extending far beyond automotive markets into national economic security. Tesla's international market share expanded to 38% as the company's manufacturing advantages enabled competitive pricing. While maintaining superior quality, European and Asian competitors found themselves unable matching Tesla's cost structure or production efficiency, creating trade imbalances favoring American manufacturing exports within decades. Export opportunities from manufacturing efficiency were creating trade surplus in automotive sectors, where the United States had been importing vehicles throughout years. Tesla's advanced manufacturing enabled American production to compete globally while creating jobs and economic activity domestically. The manufacturing revolution was reversing industrial decline spanning decades. Foreign direct investment in Tesla facilities increased by 190% as international companies sought access to advanced manufacturing technologies. Countries competed, attracting Tesla's manufacturing operations. Recognizing access to Tesla's platform technologies could provide national competitive advantages in multiple industries beyond automotive. Global automotive supply chains reorganized around Tesla's requirements as suppliers invested in capabilities needed supporting advanced manufacturing manufacturing processes. Companies unable meeting Tesla's standards found themselves excluded from increasingly important market segments. Ripple effects extended throughout industrial sectors as Tesla's techniques spread beyond automotive applications. International competitors acknowledged American technological leadership in advanced manufacturing, with governments increasing investment in domestic manufacturing capabilities to remain competitive. Tesla's breakthrough created American advantages in industrial competitiveness. Other nations were scrambling to match through massive public and private investment programs. National security implications were staggering, but the historical pattern emerging was even more significant. Tesla had triggered something unprecedented. The pattern emerges. Dr. Elizabeth Harper had spent her career studying industrial revolutions, but she recognized Tesla's manufacturing breakthrough represented something as significant as Ford's assembly line or Toyota's lean production systems. The patterns of technological disruption were emerging with familiar rhythms, but unprecedented scale and speed. Manufacturing productivity improvements matched historical industrial revolutions in magnitude, while compressing timelines from decades to years. Tesla achieved in months what typically required generational change, creating competitive advantages that would reshape industries indefinitely. Manufacturing techniques developed through Cybertruck struggles were becoming platform technologies applicable across sectors from aerospace to electronics. Economic impact projections reached $2.7 trillion as analysts recognized Tesla's innovations would spread throughout American manufacturing. The breakthrough represented more than automotive improvement. It was foundational technology that could restore American industrial competitiveness across multiple sectors. Tesla accidentally created the basis for a new industrial revolution while solving its most pressing problem. Technology adoption timelines were accelerating beyond previous innovation patterns. Where industrial revolutions typically required decades for widespread adoption, Tesla's manufacturing techniques were spreading through supplier networks and licensing agreements within years. Current Tesla employees were becoming legends in manufacturing history, comparable to engineers who developed Ford's assembly line or Toyota's production systems. Sarah Martinez and her team were creating institutional knowledge that would influence manufacturing throughout generations. Tesla employees were making history, but the strategic empire Elon Musk was building would reshape entire civilizations. The strategic empire. Elon Musk's vision had evolved from building better vehicles to creating manufacturing capabilities that could dominate multiple industries. Tesla's breakthrough represented the foundation of an industrial empire built on technological superiority and sustainable competitive advantages. Tesla's addressable market was expanding from automotive to general manufacturing as techniques developed during the Cybertruck proved applicable across industries. Aerospace companies were licensing Tesla's precision manufacturing methods. Electronics manufacturers were adopting Tesla's quality control systems. Construction companies were exploring Tesla's materials handling innovations. Technology licensing revenue projections exceeded $50 billion annually as companies across sectors sought access to Tesla's manufacturing innovations. The intellectual property created through solving Cybertruck problems had become more valuable than Tesla's automotive business. Tesla was evolving from a car company into a technology platform company, with automotive as just one application. Patent portfolio value was estimated at over $200 billion, representing one of the most valuable collections of manufacturing intellectual property in industrial history. Tesla's comprehensive patent protection covered everything from materials science to artificial intelligence applications in manufacturing, creating barriers to entry that would protect competitive advantages indefinitely. Platform expansion timelines targeted 12 additional industries over the next decade. Intellectual property was impressive, but the numbers game Tesla was about to play would redefine corporate valuation forever. The numbers game. Tesla's financial projections were breaking traditional valuation models as the company's transformation from automotive manufacturer to manufacturing technology platform created value at unprecedented scales. The numbers were becoming so large that analysts struggled to develop appropriate comparison frameworks. Revenue projections reached $500 billion by 2030 as Tesla's manufacturing platform enabled expansion into multiple industries while maintaining competitive advantages in each sector. Market capitalization potential exceeded $3 trillion as investors recognized Tesla had created platform technologies applicable across industries with combined market values in the tens of trillions. Employment creation estimates surpassed 2 million direct jobs as Tesla's expansion required skilled workers across multiple industries and geographic regions. High-tech manufacturing positions offered salaries significantly above traditional manufacturing wages, creating economic multiplier effects throughout communities hosting Tesla operations. Economic multiplier effects generated 12 million indirect opportunities as Tesla's supplier networks, service providers, and technology partners expanded to support company growth across multiple sectors. Financial analysts struggled to model unprecedented growth trajectories as Tesla's expansion challenged assumptions about scalability and market limitations. Traditional automotive analysis couldn't capture Tesla's manufacturing platform value, requiring new frameworks incorporating technology licensing, multi-industry applications, and network effects from ecosystem development. Analysts couldn't model Tesla's growth because they were witnessing the birth of the next phase of human industrial development. The future arrives. Emma Chen entered kindergarten in 2025, but her career choices would be shaped by manufacturing technologies Tesla had pioneered through solving Cybertruck problems. The future had arrived ahead of schedule, carrying Tesla's signature throughout industries that hadn't existed when the company began. Educational enrollment was shifting toward advanced manufacturing programs as students recognized Tesla's techniques represented the future of industrial work. Universities expanded engineering curricula to include Tesla's manufacturing methods. Community colleges developed programs training workers meeting Tesla's supply chain requirements. The educational system was adapting to prepare workers responding to Tesla's industrial revolution. Regional development patterns followed Tesla facility locations as communities competed to attract advanced manufacturing operations. Cities offered incentives to companies adopting Tesla's techniques. Recognizing advanced manufacturing created high-value jobs and economic development opportunities. The geographic distribution of prosperity was reshaping around Tesla's industrial footprint. Environmental impact improvements from manufacturing efficiency gains were contributing to sustainability goals while maintaining economic growth. Tesla's techniques reduced energy consumption, material waste, and environmental impact across industries, proving advanced manufacturing could improve environmental performance while increasing productivity and profitability. Quality of life enhancements in Tesla-influenced communities reflected economic benefits of high-tech manufacturing employment. Workers in Tesla's ecosystem earned above-average wages while developing valuable skills transferable across industries. Social benefits extended beyond individual workers to entire communities, benefiting from increased economic activity, improved infrastructure, and enhanced educational opportunities. Tesla transformed from near collapse to reshaping civilization itself. Their manufacturing breakthrough will influence industries for generations. American manufacturing excellence is now defining global competitiveness. What industry do you think Tesla will revolutionize next? Drop your predictions in the comments below. Thanks for watching, and I'll see you in the next one.